Hello everyone and welcome to another Bytes video. Today we're going to be doing part 1 of 3 of a button press example. So in this example we've got a button. When A0 is 1, it's on, and when A0 is 0, it's off. You can also represent that as true and false. When the button is on, you want the LED to be on, which is B1 equals 1, and when the button is off, you want it to be 0, to turn off the light. To draw a quick little photo of this, here's our button. It's not pressed. That's going to be off. And when our button is pressed, we'll do a little nice drawing. That's pressed. We want that to be on. In our off state, remember we want B1 to equal 0, and when it's on, we want B1 to equal. So how do we draw this as a state machine? Well, notice that in our real world drawing here, you've got two states. You have the off mode, off state, and the on state. We can represent each state by a circle. We have the on state, and we have the off state. Now, we're in the off state when it's not pressed. If it's not pressed, that means that A0 equals 0. That means that it's not on. And as soon as you press it, A0 equals 1, and it goes to the on state. So that means that to go from off to on, you have to press A0. That means that A0 is true. So we're just going to write that as A0 because it's true. And then when we release the button, that means that A0 is false. And we can write that this way as not A0 or false. Or we can write it that way. I'm going to leave it like this for now, but you can go ahead and write that however you want. So now we're in the off state and we go to the on state when you press the button, and as soon as you release the button, it goes back to the off state. Well, what happens if you press and hold the button? Well, that means that A0 stays true, and we need a self loop. That means that if you press and hold, A0 is still true, and it's going to stay true, and it'll stay on the on state. And that means that then when you release it and you're not touching the button at all, it's sitting on the off state as not A0. That means that A0 is, the button's not being pressed, it's off. Now, let's implement our outputs. We've got B1 equals 0 for off and B1 equals 1 for on. There's two ways we can do this. We can do this more state machine, or we can do a mealy state machine. Let's start with the more state machine. In the more state machine, you can only write outputs at the state, on the state. So that means that for the off state, we're going to have B1 equals 0, our light is off, and B1 equals 1, our light is on. That's a more state machine. I'm only writing it at the actions. A mealy state machine allows you to have the option to write your outputs on transitions. That means that I could either leave the outputs on the states, or I could do this. As you're pressing the button and A0 becomes true, that also means this slash is going to show our transition, and then this is going to be the output for that transition. That means that B1 is going to equal 1. As we go from off to on, it happens when A0 is true, and it's going to set B1 to 1. And then when we go from on to off, it means that A0 is false, and we're going to set B1 to 0 to turn off the light. That's a mealy state machine. That means that we can have the outputs on the transitions. You can still have the outputs on the states. You don't have to keep them on the transitions. That's absolutely fine. But mealy allows you to have that option. In code, it does not change what your code looks like. But if your professor is asking you for different definitions or different examples, or asking specifically for a more state machine, make sure that you write your outputs on the states. Okay, that is all for this first part of a button press example. This is the state machine. Thanks for watching.